What's the first question that comes to mind when you think of space?
Are there planets other than the ones in our solar system? Are they even safe to live on?
Are there life forms other than us? Are we alone?
Is there something out there looking for planets? How would it find them?
You may not be aware of this, but NASA's Kepler mission is answering your questions right now.
To understand Kepler, you have to know one law, Kepler's third law. This law was developed in the 1500s by Johannes Kepler.
Kepler's third law states, the time taken by a planet to make one complete orbit around its star is called its period. The planet's period is proportional to its distance from the sun.
Okay, would you break that down?
When a planet orbits a star, the star wobbles. One of those such orbits is called a period. You can determine its distance from its star via that wobble.
The Kepler mission is essentially based off of this law.
In this demonstration, we are showing our interpretation of the star wobble. As the planet orbits the star, its gravity is pulling the star so it tilts towards the planet. We can measure the planet's size based on how much the star wobbles. The larger the wobble, the larger the planet.
Now that you know about Kepler, let me tell you about the 5 main goals.
The first goal is to determine the amount of terrestrial and larger planets in or near the habitable zone.
The second goal is to determine the shapes and sizes of each planet's orbit.
The third goal is to estimate the amount of planets in a multi-star system.
Goal 4 is to determine planet sizes, densities, and orbits.
Goal 5 is to discover other planets and determine the properties of their stars. So what is Kepler exactly? It's a probe that's 2.7 meters in diameter and 4.7 meters high. It weighs a total of 1,052.4 kilograms.
Kepler was launched March 6, 2009. The Delta II rocket that carried it was launched smoothly.
The spacecraft then observed stars that are a few hundred to a few thousand light years away.
This may not seem incredibly far, but in case you aren't aware, a light year is 6 trillion miles away.
Kepler is watching an area that contains about 100,000 stars. Each of those stars are similar to our sun. It watches each of the stars continually to notice any changes.
We've all imagined living on another planet.
It seems so cool.
But how do we know if life is possible on that planet?
Kepler can identify that.
The Kepler probe contains a photometer. This telescope-related tool does this by determining the brightness of the star. It then can calculate the distance away from the star where water can occur in its liquid form.
This is known as the habitable zone.
A photometer doesn't actually take photos, it measures light rays. When the planet is between the star and the Kepler module, it makes a small eclipse that the photometer can record. From this data, we can measure the size and distance from the star. This method is called the transmit method of planet finding. The Kepler mission is a lot like the story of Goldilocks. Here's our version of the tale. There once was an extraterrestrial girl who grew bored of her home planet. She wanted an adventure, so she decided to find a new home on another planet. She found many planets in space, but they all seemed to have problems. And another was too hot. Some were too big, and some were much too small. But one day, she found the perfect planet. This planet is known as Kepler 22b.
So far, there are 2,321 planet candidates. 61 of those are confirmed as planets. And of those 61, one is located in the habitable zone. This special planet is known as Kepler 22b. It is 600 light years away from us, but it's the Goldilocks planet.
Why is it that only 61 out of 2,321 candidates were classified as planets?
Planets have certain qualifications.
The current definition for a celestial body to be considered as a planet was set by the International Astronomy Union in 2006.
To be a planet, a celestial body must be in orbit around a star,
have a sufficient mass so it will have enough self-gravity to make itself nearly round,
and has cleared the neighborhood of its orbit.
in simpler terms, the planet must have a predictable path around a star,
Be large enough so it is round.
and doesn't have any objects in its orbit's way. Kepler 22b isn't the only interesting find this mission has come across. New information reveals that planets have been found that orbit two stars at one time. These planets are called circumbinary planets.
Two of these planets are Kepler 34b and Kepler 35b. These two planets are about the size of Saturn. Kepler 34b orbits its stars every 289 days, but the interesting part is that the stars orbit each other every 28 days.
They cause eclipses, which help us determine the precise size of each star. The photometer is what helps these special solar systems to be discovered. Its continuous measure of the star's brightness, insanely good precision, and ability to observe over 100,000 stars at all times allowed us to make this discovery.
Information from Dr. Jerome Oraz, as co-author from San Diego State University, says these planets can have really crazy temperatures that no other type of planet could have.
Now you know that Kepler is making observations outside of its goal. We are now showing a model of a circumbinary solar system. The two balls in the middle are the two stars. Notice how they orbit each other. The smaller ball is a planet, such as Kepler 34b or Kepler 35b. Kepler is still out there searching. Since it is searching for planets of Earth's size and distance from the star, each transit period should take about a year. Results are expected to appear in 2012 to 2013. Hopefully, it will find more planets like Kepler 22b. The possibility of humans moving out to a planet like that is not probable because it would take so long to get there, even if we could travel at the speed of light. The next step, after Kepler, would be to determine the planet's atmosphere so we could understand its climate. Then we could determine if the planet could sustain life. So one day, when you hear about a planet being discovered with life, remember the Kepler mission.